Dear students, you may wonder how we are going to use all these information about orthographic projection as architects. First of all, we need to understand that from now on, we will be always using the orthographic projection and sometimes if the planes, lines, or surfaces, if they are not perpendicular or parallel to either of these projection planes, then we will not be able to see the object's true sizes. Because from now on, we will be always drawing the objects through its upper views or frontal views or side views, or we are going to cut them in half and call it a plan or a section. And in order to move on for the production step, we need to find the actual sizes of these objects. And this will be very difficult for us if we are dealing with inclined objects. Here, with this method, with Epirov-Monge, the method that has been created by this mathematician, it will be very easy for you to find out the actual sizes of these objects. I am just going to give you two examples. Normally, all these subjects were included in the course, but unfortunately, we don't have time for these stuff. So that I will just use these slides to give you the example, to express you how we can use it. Let's say that we have an oblique line, and we can be sure that if I am standing here at the above the system and looking downwards, the projection, the first projection of this line will be shorter than its actual size. And this will be the same for the frontal view and the side view. So with its orthogonal drawing, I cannot be able to find out its actual size. And let's say that I designed a building, and this is just the edge of one of the walls, or maybe the edge of the roof. And I need to know its actual size in order to move on to the construction phase. And there is only one way for me to find out its actual size. I need to make the model, or I need to use a software program or something like that. Well, with this method, it can be very easy for me to find out. I don't, let's say that you don't have a perspective view, you just created this drawing by using two numbers. And this is what you can do. This technique is called transformation. And it means that this line will be laid down on the surface of this projection plane. Here you can see its traces. It has two traces, and I will be doing this. I will be using this point as the fixed point, and I am going to rotate this line by using this point as the center of rotation, so that I will be able to find its actual size. Once I find the trace, and this is how I can do. Imagine that I am here, I am looking at the system in front of it, and this is the representation of horizontal projection plane. This is the representation of profile projection plane. And if I just keep keep going for this line. And when it intersects with the horizontal projection plane, I can say that it is its trace, one of the traces of this line. It goes through the horizontal projection plane. So if I just transport this point downwards and draw the rest of the line, this is, I can say that this is one of the traces itself and its first projection. Since I found this point, now I can use it as my reference point or as my central point. And this is what I need to do. Once the line is laid down on its side, these levels will be the same because they are perpendicular to each other, to this surface here, as you can see. So I can use this information to find out the actual size of the line. This is what I need to do. Here, there is the trace, and this is the level of point A, and this is the level of point B, and it is perpendicular. And if I draw two perpendicular lines at the projection of these points on the projection of this line, and I need to calculate the level and find the points. And once I combine these three lines, I will be able to see its transformed situation. So this is what I need to do. By using these 2 points, I need to draw 2 perpendicular lines and indicate the level over these lines here. This distance, this length should be transported here, and this length should be transported here. And once I combine these, as you can see here, they are the same. This length and this one is the same. And once I combine all these 3 lines, this is the true line, the true size of the line. And I can do the same by using another trace point, another trace of the line with this vertical projection plane. But this time I will be using not the level, but the interval as the distance, as the length. And I will be laying this line over the vertical projection plane. I will do the same. This interval, this length will be transported to here on this perpendicular lines. So this is what I need to do. I need to draw 2 perpendicular lines that starts from the second projection of these points. And I need to transfer this length over here and over here and indicate the endpoint. And after that, once I combine these 3 points, the trace, and these 2 new points, I will be able to see the actual size of this line. And this will be same with the planes as well. I will show you another example here. Let's say that we find by combining these lines, we created a plane, a triangular plane like this. But I won't be able to see its actual size on the top view, on the front view, or on the side view. On the top view, I will just see it as a line. I cannot be able to understand that it's an actual plane. But on the front view and the side view, I will realize that it's a plane, but I will think that it is smaller. I will see it in a smaller version. This is what I draw by combining these lines and points. But for the production purpose, I need its actual size. So I can do the same again, but this time by using this projection of this line here, I can lay this triangle over the horizontal plane by using the levels here, levels of this line, level of this line, and level of this C point. So I need to draw two perpendicular lines, additional perpendicular lines that starts from this first projection of this line and point D. And I need to, as you can see, I need to transfer this level over these lines and indicate the endpoints like this one. As you can see here, it's the level of point C. I just calculate, I just measure the distance, the length here, and indicate the endpoint. And this is the level of point D. I just indicate the endpoint, and I just draw a parallel line to this projection. And once I combine these two points, I will be able to see the actual size of the of this plane.